Hey guys, I'm going to walk you through some of our thinking from page 5. So it says, given the geometric figure and a rotation, reflection, or translation, draw the transforming figure using graph paper, tracing paper, or geometry software and specify the sequence. So how did it go from point A to B to C? Okay. So when we look here, it says, how did this object, I named it ABCD, ABCD, how did it get here to this dotted line? So if we notice here, we can look at the coordinates, and there's two techniques we used on the last page. One, you can look at the coordinates, just look at the coordinates, or you can actually graph it. So remember, if something rotates 180, a coordinate that was, if C was at -3, +1, it should be, if it rotates 180, it should be at just changing sign, 3, -1. And we notice that works. So we can graph it and move it. You can also trace it on a piece of patty paper or notebook paper that's easy to see through and turn it 90 and then turn it again 90. Either way, we notice that by rotating it 180, that's how we land on the dotted line. So you might be thinking, what is all the other notes you guys took in class? Well, we notice on B, translating right and down. So here's our object. Translating it right would move it over here, right? And then scooting it down would land it right there. And that's not going to work because it still would be if this is kind of an arrowhead, it's pointed down, and we need it pointed up. So we know translation is not going to work because translation keeps the orientation, and this has a different orientation. If we look at C, it says reflection across the x-axis. So if I reflect over the x-axis, I'll land here. So if you're wondering, how do I draw that? Remember that it's a perpendicular bisector. So if I reflect over the x-axis, if C was 1 up, now J is 1 down. If D is 2 up, then M is 2 down. If A is 4 up, then M would be, or L would be 4 down. Same here, B 4 up, so K 4 down. That would be where it would land, and notice this shape is not the dotted line. If we reflected across the y-axis, this object would land here using that same technique. So we definitely see A is the correct answer. Question 2, it says, triangle ABC and triangle DEF are graphed. What sequence of transformations maps upon itself? So we try question number A. We say a reflection over the x, okay, that would be here, using the technique I just used. And then a reflection over the y would land here, and I land right on top of my shape. So we pick A. We're preparing, though, for what if they have questions, check all that apply. We need to be prepared, right? So let's try B. It says, what if you rotated here 180? Okay, so then you'd be there, which is good. But then they also want you to reflect it over this line, y = x. So if you reflect it over y = x, the orientation will actually be slightly different. It'll look something like that. So meaning D wouldn't move, but this coordinate is, 1, 6. And now it would be swapping spots, 6, 1. So F prime would actually be over here. E is 3 something, so yeah. So this is where that shape would be. Notice it's not mapping on top of DEF. It's slightly different. So we notice B is not correct because it is a slightly different orientation. Let's look at C. It says a 90-degree clockwise rotation. So if we rotated this clockwise, all right, so that would mean I'd be somewhere here because I'm going to move clockwise. And then reflect over the OR axis, I'm going to be pointed slightly different again. So these are very good test questions because both of these end up in the right quadrant, but a slightly different orientation. What about the last one? If I translated ABC 8 units to the right, so 1, 2, 3, 4, 5, 6, 7, 8, everybody moves 8. So it'd be somewhere there. Oh, wait, and 1 up. So everybody moves 8 over and 1 up. So something like that. Then a 90 rotation counterclockwise. Oh, I think I got this in the wrong spot. So 8 and then 1 up. All right, so I'd be somewhere there, 8 to the right, 1 up, followed by a 90-degree rotation counterclockwise. I end up in the right quadrant, but I end up being pointing like something like this. So all of these are very difficult to see, but I'm ending up once again in a different orientation. Let's say you're not good at graphing, like I'm graphing on top of here and I'm actually tracing and seeing how they're moving. You can also use the coordinates themselves to see that. So going back to your form and using these rules and seeing if you land on top of the point you are anticipating to land. Question number 3. It says a triangle has these vertices. Which transformation would produce an image with the vertices? So we see that the -3 is now a +3. A -6 is now a +6. A -1 is now a +1. So the x value changed signs. We notice here the y value doesn't. So when we notice that, we can graph these, or we can just graph the first couple and then be like, yeah, I see what happened. If I graph -3, -1, then I graph the new coordinate a prime, +3, -1. It looks like it flipped over my y-axis. I can do the same for B and C, moving it to B prime and C prime, but I'm going to get the same answer. So I've now found a new rule to add to my sheet. When you reflect over the y-axis, then what happens is, oddly enough, the x value changed the sign, but the y stayed the same. That's probably the opposite of what you might think. So the y stays the same when you flip over the y-axis, but the x changed signs. Okay. So question number 4. A triangle has a vertices of -7, 6, 4, 9, and -2, 3. Where do these units come from? Okay, so walking through this, we notice that the coordinate, -7, 6, just going to recopy this. 4 units to the right, we know that to the right is x, positive x. So we're going to add 4 to each x value, and these are the x values in the first position. And then it says 6 down. So 6 down would be in the y, down, down. We want to go down 6, down 6, down 6. So our final coordinate is, when we take -7 plus 4, 6 minus 6, 4 plus 4, 9 minus 6, -2 plus 4, and -3 minus 6. We get the answer D, matches our coordinates. We could graph this as well, but algebraically it works pretty clean. Question number 5, it says, can stack 2 cubes on top of itself? So this is a very interesting thing here. I drew this off to the side to kind of get an idea. So let me walk you back through my steps. This cube is actually just like a real die. This is true on a die, except these, instead of the number 6, is usually 6 dots. They're saying each cube is numbered to the opposite face. So if the top is 6, the bottom would have to be 1. If this is 2, then this back side we can't see has to be 5, because 2 and 5 is 7. And this side 3 would have to be 4 because 4 and 3 is 7. And that's all 6 sides. There's 6 sides to a dice, 6 sides to a cube. Now they're saying, which is very interesting, we haven't done transformations with 3D objects, and now we are. So we notice that this 6, if we call that pointing up at 12 o'clock, we notice it looks like it's now pointed this way. So it's rotated 90 degrees clockwise. That's right off the bat why we like B. The top moved 1 position. Now let's take a look at the bottom. So our bottom cube, 2, is now showing a 5. So that must mean we twisted it. By twisting it once, the number 3 would be there. And then twisting it again, the number 5 would be there. So it looks as if we've twisted it twice. Well, 180 is when you twist it twice, 2 positions. So we get our answer B. Question number 6, last one on the sheet. It says, it says, in the figure show which is a composition of rigid motion which will map one triangle on the other. So we see here that it's definitely not 2 translations because one is the upside down of the other. All right, so it's definitely not 2 translations. Remember, translations don't change orientation, and this orientation has changed. D is definitely out. A rotation followed by a translation. A rotate would keep point D on the left. See how point D, if you rotate it, let's say you spin it around any amount, and now D here is spun around there, it's going to keep D on the left, and we need D on the right. So spinning it is not going to help. So let's look at the top 2. I think there's an argument to be made for either one. But in class, when we discussed this, we looked up the word glide reflection, and it said it's a composition of first a translation and then a reflection over a line. So first we're going to translate it. So if we scooted it over, it would be somewhere here, right? A prime, B prime, C prime, D prime, and then we would reflect it over a line. So it looks like if you flipped it over this line, this would be the perpendicular bisector, right? So it definitely looks like we flipped it, scooted it, and flipped it. The problem is, notice that there's 2 primes here. And so if this was considered one combination or one composition, then you would go from A to A prime, and you wouldn't label the interim. So that's why if I had to pick a best answer, I would pick B, because let's try that one as well. If I reflected and then translated, so if I reflected, let's see. So instead of that far up, I'll go that far down. Instead of this far up, I'm going to go that far down. Instead of that far up, I'll go that far down, that far up, that far down, far down. So that would give us something like this, right? And we label it because it said followed by. So our reflection, it gets flipped and we label. And then we translate it, and that looks like it would fit perfectly on top. So that's why I think B is the best answer. I technically think both are right. Thanks for joining us, guys. Check out the next video for page 6.